Welcome to lesson 25 of Saxon Math Intermediate 5. Today we're going to talk about listing the factors of a whole number. So go ahead and open up your math notebook at the top, write lesson 25 notes and the day's date. And let's go ahead and get started. Just like always, if you need to pause at any time, feel free and then you can jump back in as soon as you're ready. So go ahead and copy down power-ups A through H and work out those equations on your own. The goal is to be trying to get faster and faster each time that you do these power-ups. So you want to work well, but you also want to try to increase how quickly you can get them done. Remember that if it says centimeters or inches, then you need to, or minutes, then you need to include those things in your answer. Okay, so we know what we're discussing. All right, go ahead and take your time. When you're done, go ahead and push play again. All right, we're moving on to power up problem solving. Remember, we have not worked on our power up problem solving for a little while, so we want to remember the steps. The first step that we always want to do is we need to understand the problem. So the best way to understand the problem is to take some time to read it carefully. Okay, so let's read this problem together. Hamdi was thinking of a two-digit even number. Hamdi hinted that you could say the number when counting by threes and when counting by sevens, but not when counting by fours. Of what number was Hamdi thinking? Okay, this is a little bit different kind of problem than we've done before, so we need to think about it and understand very well what kind of information we're given. So we're going to list out the information that we have. Okay, we're going to write it out on our paper. The information that we're given, the first information that we're given is that Hamdi was thinking of what? A two-digit even number. Should have that written out on your paper under the title Understand. Okay, that's the first thing that we know. The second thing we know is that we say the number when counting by threes. I'm going to use the number sign. You can too. And the third thing we know is that you also say the number when counting by what? Seven. Good. All right. And the last thing we know is that you do not say it when counting by fours. All right, so now we understand our problem. Now we need to know, what are we asked to do? We are asked to think of the number or find the number he's thinking of. Almost sounds like one of those magic card tricks, right? Okay, so now that's under understand. The next part is that we need to make a plan. Okay, we need to make a plan. So let me add understand up here at the top, because I did not do that. Oops, gonna shift all my. Okay, so we have understand. Now we're on plan. Okay, our plan, we could make a list, right? We could make a list of multiples of 3, 4, and 7, and then look at the numbers. All right, if we started listing only the multiples of 7, how might that help us find the answer more quickly? Think about that for a minute. If we start listing only the multiples of 7, how could that help us find our answer more quickly? It's because there's less multiples of 7, right? So why don't we start with that? Let's go to solve. Okay, we're going to start out with listing our multiples of 7. Multiples of 7, we have 7, 14, 20, oh, let me put commas here. 14, 21, 28, 35, 42, and 49. Let's go with that. And we know that that continues. Which of these numbers could we eliminate quickly? Which numbers could we eliminate quickly? Well, we could eliminate, we can eliminate all the numbers that are a 1-digit number and all of the odd numbers, right? Because it says he was thinking of a 2-digit even number. So we know we can cross out 7. We can cross out 14 because it's an even number. We could cross out 28. We could cross out 42. Okay, now, oh, I'm sorry. I did that wrong. Let me undo that for a second. Let's see. Sorry, we can cross out the odd numbers because he's picking an even number. Sorry about that. Okay, so we're going to cross out this one, and this one. Okay, that leaves us with 14, 28, and 42. How can we eliminate the other numbers on our list? Well, we could eliminate the other numbers because it's a multiple of 4. We could take out 14 because 14, it says it's not a multiple of, we don't count by 4s. So we can take out 14. And because it's not a multiple of 3, and we can check the number 42 and see if it fits. And we could take out 28 as well. Okay, so we have 42 here. Let's see if 42 will fit all of our criteria here. Okay, so now we're going to check our work. Let me get back my text here. We're going to move on to check. Okay, and we're going to check our work. We're going to see, is 42 an even number? Yes, it's an even number. Okay. Do we say it when counting by 3s? Yes. We say when by 3s. And do we say it when we're counting by 7s? Yes, we know because we only did multiples of 7. Yes. We'll say yes. It is a multiple of 7. Good. And finally, do we not say it when we count by 4s? That is true. We do not say it when we count by 4s. Okay, so we checked our work. So we know that our answer is 42. Good. All right. Let's move on, shall we? Moving down. Let's talk about factors. factors of a number are are the whole numbers that can divide it without leaving a remainder. Sorry about that typo there. That threw me off for a second. I did not write these slides. They were passed down to me. So the factor of a number are the whole numbers that can divide it without leaving a remainder. So how could we find the factors of 6? How could we find the factors of 6? Well, we can look at which numbers can go into 6 without leaving a remainder, right? So the factors of 6, for example, would be what? Let me make this font a little bit bigger here. The factors of 6, we could say are 1, right? Because 1 can go into 6 times and not leave a remainder. 2 because 2 can go into 6 times and not leave a remainder. It would go in how many times? 3. Good. How about 3? Yes, 3 can go into 6 2 times without leaving a remainder. What about 4? No, not 4, because 4 could go in 1 time, but there would be a remainder. What about 5? No, because there would still be a remainder of 1. And then lastly, it would be 6, okay, because 6 can go into 6 1 time, and there's no remainder. Then we're done. There's no more, okay, because it's a little number. So finding the factor of a little number is obviously going to be easier than finding a factor of a big number. But there, we just did it. Not too difficult. 1, 2, 3, and 6. Okay. Let's do one that's a little bit harder. List the factors of 20. Ooh, the factors of 20. There's going to be a lot, right? The factors of 20. Let's see. Well, just like the 6, we know that 1 can go into 20 times with no remainder. We know that 2 can go in, right? 2 can go in how many times? 10 times, because 10 times 2 is 20. Good. How about 3? Can 3 go in? Not 3, no. How about 4? Yep, 4 can go in with no remainder. How about 5? Yep, because 5 times 4 is 20 and there's no remainder, right? How about 6? No, because 6 times 3 is 18 and we couldn't get it in there anymore, so there would be a remainder of 2. So 6 does not work. What about 7? No, because 7 times 7 is 14. And if we add one more 7, it'd be 21, so it'd be too much. So 14 would leave us a remainder, so that does not work. What about 8? No, 8 again does not work because 8 times 8 is what? 16. And if we added another 8, it would be too much. It'd be more than 20. It would be too much. It'd be 24. So we know that 8 does not work. What about 10? Yeah, we already know that one, right? Because we said 2 times 10 is 20. So we know 10 goes into 22 times and there's no remaining. All right. And our last one would be 20. Because anything more than 10, even if you doubled it, would be over 20, right? Because 10 times 10 is 20. So we can't go anything higher than 10 except for the number itself, right? Because it goes in 1 time. All right. Good. Example 2. Now we're going to list the factors of 23. List the factors of 23. Go ahead and get started. See if you can do that. Okay? Let's see if we can list the factors of 23. I'm going to give you a hint. There's only 2. There's only 2. Can you find them? There's only 2. 1 and 23. Those are the only ones. There's only 2. 1 can go into 23 times. And 23 can go into 23 1 time. That's it. Anything else is going to give us a remainder. All right. There we go. So sometimes we can discover that some factors of a number just by looking at 1 or 2 of the digits. For example, a factor of every even number is 2. And any whole number ending in 0 or 5 has a 5 as a factor. Since 20 is even and ends in a 0, we know that both 2 and 5 are factors of 20. So sometimes knowing those little things will help you get some of the factors right. Let's read that again. Sometimes we can discover some factors of a number just by looking at one or two of its digits. For example, a factor of every even number, every even number is 2. Okay, so if I tell you to find the factors of 36, you know 2 is one of them. If I tell you to find the factor of 8, you know 2 is one of them. No matter which even number, 2 is going to be one of them, okay? And any whole number ending in 0 or 5 has a 5 as a factor, all right? So any whole number that ends in a 0 or a 5 is going to have a 5 as a factor. Okay, you want to remember that. So that way when you're listing out factors, you at least know one or two of them, right? And since 20 is even and ends in a 0, then we know both 2 and 5 are factors of 20. Okay, so those are some tricks to help you find at least some of the factors, right? They can help you. All right, let's look at example 3. Which of these numbers is not a factor of 30? Not a factor of 30. Well, we know what? We know that it's a whole number that ends in a 0. And what did we learn about whole numbers that end in a 0? We learned that 5 is always going to be a factor. So we know that one's good. All right. And what did we learn about 2? 2 is going to go into any even number, and 30 is an even number because it ends in a 0. Okay, so that 0 told us about the 2 and the 5. So now we just have to look at 3 and 4 and determine which one of these is not a factor. What do you think? Well, 30 is divisible by 3, right? Because 3 goes into 30 how many times? 10. Good. 10 times 3, 30. But 4 is not, 30 is not divisible by 4. So 4 is not a factor, okay? But 4 is your answer. 4. Got it? All right, process of elimination. Which factors of 9 are also factors of 18? Well, the factors of 9 is what we're going to have to write out first, right? So that we know. We know the factors of 9 are 1, because 1 goes into 9 times. 3, well, we can skip 2 because 2 is an even number, right? And it would leave a remainder. So we know 3 goes into 9 3 times, so that's got to be a factor. And we know that 9 goes into itself 1 time. Okay, there's our factors of 9. Let's look at our factors of 18. Well, we know that 1 goes into 18 times. We know that 2 could also go in because it's an even number, right? We know that also 6 goes into 14 or 18 evenly 3 times. Okay. Oh, but we also have 3, right? Let's not forget our 3. Okay. So we have 1, 2, 3, 6. What else do we have? 9. 9 goes into 18 2 times. And we have 18. All right, there's our factors of 18. So which factors of 9 are also factors of 18? Let's underline the ones that are the same. 1, 3, 9, right? 1, 3, 9. Good. Now, what is the greatest common factor of 9 and 18? What's the greatest common factor that they both have in common? The 9, right? That's the greatest common factor. They both share the number 9. All right, good job. Moving on. All right, here's some lesson practice. Write the factors for each of the following numbers. Okay, so that's your job. Write the factors for each of the following numbers. We'll do a couple of them together and then you'll do a couple of them on your own. All right, let's start with A because that's the logical place to start. The factors of 4 we know are 1 because 1 goes into all of them, right? We know is 2 because it's an even number. We know is what? 4. Okay, 3 can't be it because 3 would have a remainder of 1, right? So our factors for number 4 are 1, 2, and 4. All right. Let's go on to 3. What are our factors of 3? We know 1 again goes into 3 3 times. That's the easy one. Does 2 go in? No. So just 3. That's it. Just those two numbers, 1 and 3. Not too difficult. Okay, let's see about factors of 6. What could go into 6? Well, we know because we've already done this, right? 1 goes in because 1 goes into 6 6 times. We already said that 2 goes into 6. We also know that 3 goes into 6. And we know that 6 goes into 6. Okay, and all of those go in without leaving a remainder. That's the key, that you want to leave no remainder. Okay, because 5 can go into 6 one time, but it would have a remainder of 1, so that does not count as a factor. Okay, let's do. You do D, E, F, and G on your own. D, E, F, and G on your own. When you're ready, come back and push play. All right. Let's see how we can check this division problem. Okay, let's see how we can check this division problem. Okay, we have 6 goes in to 75 12 times with a remainder of 3. Well, the best way to check it that I know is to do 6 times 12. What is 6 times 12? Well, 6 times 2 is 12. We're going to carry the 1. 6 times 1 is 6 plus 1 is 72. Okay, and then we're going to go here. We're going to minus. 5 minus 2 is 3. 7 minus 7 is 0. The 3 became our remainder, just like we practiced last week. All right, so we know we got the right answer. It worked out just right. All right. Here is your homework for today. It's pages 157 through 158, numbers 1 through 30, but you're just going to do the even problems. Okay, just the even ones. No stressing. Right, nice and neat. All right, have a great day. I'll see you later.